When it comes to naming molecules, there's a lot of things you need to keep in mind, and it can often feel like a bit of a daunting task in and of itself, but this video will help make all of that much easier. The first thing you need to know are the roots, because much like any great tree, this is what the rest of the names will grow from. The root term you use will tell just how generally big the molecule is by identifying the longest carbon chain. They are pretty easy to remember also, since all but the first four go off the basic geometry naming style. If it's 1, it's meth. If there's 2 carbons, it's eth. 3 is prop, and 4 is bute. The rest have the same naming style as the prefixes for polygons. 5 is pent, like pentagon, 6 is hex, like hexagon, so on and so forth. For the first 4, just remember the simple acronym MEPB, or Monkeys Eat Peanut Butter. Next, check to see what the largest carbon-to-carbon bond type is. This will determine what the end of your root will be. If it's all single bonds or alkanes, it'll be ane. But if there's a double bond or an alkene, it'll be ene. And if there's a triple bond or an alkyne anywhere, even if there are alkenes, the root will be ine. Now, before we go any further, we need to talk about priority, because in addition to the root, you also have prefixes and suffixes. While a molecule can have multiple prefixes, it can only have one suffix, and you may come across one that has a couple different options for what its suffix can be. So how do we know which one to use? We use priority, an arbitrary system that assigns different importance to different functional groups to help clear issues like this up. Here you can see a table listing different functional groups in decreasing order. A good rule of thumb to remember is that generally, the more complex the functional group is, the higher priority it will have. And the one with the highest priority will be the suffix. When naming a structure, we want to make it as clear as possible what the molecule is and how it looks. To help with this, we number each carbon in our longest chain and refer to that number in the name when talking about anything that isn't the beginning of the root. And yes, that includes enes and ines, but anes from alkanes can be excluded since they're the most basic and they're everywhere. But there are 2 ends that you can start numbering from, so be careful. When numbering, you always want to make it so that the highest priority functional group has the lowest possible number. If it's directly in the middle, then go on to the next group. There are a few more little quirks to keep in mind when naming. For instance, if your carbons are in a ring, simply add cyclo to the beginning of the root, such as cyclohexane. Also, when the name has multiple prefixes, they should be put in alphabetical order. Now, these last 2 you probably won't have to use until much later in the course since they deal with molecular geometry, but it's good to know them anyway. When you have a chiral center, which is a carbon atom whose 4 bonds each consist of different substituents, you need to label it R or S. To do this, you need to assign an order of importance to the bonds, an order of 1, 2, 3, and 4, with 1 being the most important and 4 being the least. This importance will be determined by the mass of the atom that is directly attached to the chiral carbon, with the highest mass receiving the highest importance. If there's a tie, look at all the atoms attached to those ones. Also of note, if there's a double bond, that will count as 2 of the atom that's attached, and if there's a triple, that'll count as 3. Then look at it as though the least important atom, 4, were going directly away from you. If the numbers of the others are going clockwise, then it'll be R. If they're going counterclockwise, it'll be S. Remember, R for right way around. Also, for any alkenes present, the double bonds, you'll need to label them E or Z. To do this, look at the 2 bonds on each side of the alkene to determine which is more important using the same system we just used. If each side has the more important bond going in the same direction, such as both of them going up, we will use Z. Whereas if they're going in opposite directions, one up, one down, we will use E. If either side has a tie for importance and cannot be determined, then the EZ cannot be assigned. And there you have it. Just follow these rules and you'll be able to name any organic molecule you come across and know exactly what's being discussed when IUPAC names are being used.